So today we are learning the most easy and most hard data structure, or like most common data structure. You could call it stack. Uh, the definition of stack, I guess everyone is familiar with that. It's the last in, first out, or the vice versa case. That LIFO or FILO, right? And just swap this. It's same thing, right? But useless definition. Uh, Main, if you wanna consider stack in thought process perspective, you should always consider it as a list. And if you want to be more flexible in your thoughts, consider it as a state management kind of thing. Like if you want to give more flexible thoughts on stacks, why is this pen? Okay, more flexible. You could think it as like this, that this is your state, let's say ABC. Now at time t1, it could be something like this, AB. So the state graph would be something like this, that delta 1 to this node, delta 2 to this state. Basically you will record only the change you are doing to the data structure, right? So if I did in this case, if I did add remove the C, I will just store this delta in my graph anyway. Like that's the another thing. But uh, for most of the use cases, just consider stack as a list, a dynamic list. And also for implementation wise, you can always use, like in Java, dynamic list. I guess list is dynamic in Java, array list. And in C++, obviously you can use vector as a stack. There is pop back operation in C++, and emplace back or push back. So you will get more control over your data structure instead of using just stack internals. Like STL has stack library, hash include stack, but you should always use vector. Why? Because vector has two operations, like pop and pushback, so it will act as same as stack and list. Uh, but if you are more used to this kind of visualization, like the vertical visualization, then you might be use stack, like no issues. But if you use vector, like you will have more granular control over your data structure, that you can access those indexes to, like 0 1 2 3 and all, and many things you can do with that. But always try to use vector, not just stack. Anyway, this is the one thing. And yeah, horizontal representation we have done. uh, Now we will start with more flexible we have done. Okay, application of stack. Most of the real world applications are converged to stack. Like uh, I don't know how to say this, but like usually you can say that stack can be used at many places, but I think the real world changes were different. Like they were, most of the cases in real world applications have some kind of like similarities to stack. So they kind of like use a name as, like, we are using stack for this, for storing updates, for like in your databases. There are like stack processing, yeah, like browser, anywhere, like ID. So incremental updates are used, done using stack. So most of the cases are similar. But you can say that like stack can be used here, app1, app2, app3, or you can say that app1 have used similar functionalities like stack, app2, app3. Like you can call it like MS Paint, let's say, your normal text editor, your control C, control V, right? You do that also can be done using, there is internal cache for this thing, that you will use stack in that. Many applications for stack. Okay. uh, 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 let's jump to another point after this. Let's start with the parenthesis session that we have. You guys are here for that. Okay. So that was just an intro for stack. Mm, I didn't use the monotonic. Acha, okay, let's discuss monotonic stack if there's time remaining. Let's just focus on parenthesis session today. So, like I don't remember this as like parenthesis session. I use just brackets, right? Like curly braces and all. But I guess the title in this, I don't know that which website. I guess Frats, the YouTuber's website. It is, I guess. They have used this word, so I'm using this word for the session. Again, like this is not a category. This is a this is name for learn. Yeah, I guess. Yeah, sorry, I didn't remember. I never saw that before. One of my followers sent me that website, and I saw that. Okay, so parenthesis session. Parenthesis is not a category basically. These are just similar types of problem that mostly in our real life we use parenthesis a lot. So when the tasks are kind of like under development, like let's say you want to create a new task, so it's highly likely that task will be related to parenthesis, right? Because even your normal programming task like in asked in interviews are designed similarly, like LRU cache and all, because they are used everywhere. So the so let's say someone is kind of trying to solve that task and they figure out that's a problem they faced, and they will just ask the same sub problem in your interviews. So hence parenthesis session, oh sorry, parenthesis tasks are asked a lot in interviews. One person today told me that it was asked in his interview also. The same task that we'll discuss later. Okay. Uh, 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 uh. Okay. So parentheses or braces or brackets are just to maintain the priority. अच्छा, you only care to in me show. Okay. Uh, Parentheses were just invented to maintain the priority. Mostly it is related to priority, like not talking in English text perspective. In that case, it serves a different purpose. But for parsing and all, the brackets are just for priorities. Like because all you do is text parsing, right? Like in programming. So for text parsing, brackets are just for priority. And the definition is that, like let's say my string is something like this abc. So if I need to add another valid string to this, it will become the new valid string abcd, something like that. Or you can also write it like this to maintain the priority: 2 plus 3 into 5, because this multiplication, I don't know what the weightage or like the priority for multiplication is higher than addition. Hence, we use bracket to deal with that. Okay. Uh, 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 uh. This is the generic definition of valid parenthesis substring. Let's jump further. Okay. So most of the common thought nodes for parenthesis are related to prefix sum, greedy, and height. Like why prefix sum? First discuss that. So let's say let's take a simple example. Valid parenthesis. Let's say prefix sum. By the way, don't get confused with prefix sum. It is more related to the plus one, minus one kind of thing. Just that in the prefix, our total number of closed bracket should not exceed than the number of open brackets. Hence, we kind of like convert this to mathematical task that let's say this is my string, right? So instead of counting in prefix, I could just use prefix sum, plus one, minus one, minus one, minus one. And the moment I got minus one extra here, like plus one, minus one, zero, and then minus one, then I know that like I have extra closed bracket. this extra close bracket makes our string as non-valid, because all we need to do is pair every open bracket with the closed one, because that's the definition that if the string is valid, we can just uh, convert it to valid string via like this. So if I add here, I should also add here. But if this bracket doesn't have this extra open bracket, then this becomes non-valid. Hence, the generic definition is that uh, it's total, every open bracket has close bracket for it, right? So it also shouldn't be like this, that because this open bracket doesn't have any closed bracket for it. So this is also not valid. This is also not valid. Whew. Prefix sum. Uh, Let's take the simple example how to check the validity. So to check the validity, you can either use this stack. Let's say there are like multiple types of brackets like this, square, round, curly, and all. So if this is the case, then you can't use a single variable +1 -1. Then you need to think in 3 dimension, right? Because this is a linear dimension on x-axis, then it's okay. But like if there are multiple, then you need to go via different vector. Like this could be on y-axis, this could be on x-axis, and this could be on z-axis. In the end, you should be land on origin. But thinking in terms of different directions for this extra brackets is kind of dumb. Instead, what we could do is just maintain a stack that will because all we need to do is make sure our string is balanced always, right? So even if s is converted to s like this, then let's say s1, s2, and then let's say I added something like this, s2, s3, something like this. So all we need to do is just use stack to maintain those addition pairs, right? So what we could do is do the parsing or processing or traversal, whatever word you want to use. We should always go from left to right. That's the usual order in programming. So, we start with this. Let's say this is my target string. So I will push this bracket here, and the moment I reach here on the, obviously rest of the characters will be ignored in the processing, because all we are worried about is that the total bracket should be balanced. So the moment I got this, I will pop this from the stack, and I know, like, so it means until this prefix, my stack is valid, right? Then after this, I will push this bracket, then I will get this bracket, then I will get, the moment I got this, I will again remove this, then I will again push here, then I got here, then again I will remove this, then I got this, then the moment I got this, I will remove this. uh, I am storing this vertically because I don't want to erase this. This is kind of a way to write incremental updates, so you can write it like one on top of each other, so you don't need to erase that. Okay. So this is the way you can check if the string is valid or not. uh, so this is the lead code. First, valid parenthesis, also valid parenthesis, or any checking task for if it is valid or not. uh, I guess in when you type in your id, they have a different mechanism, so that I guess they have the same stack mechanism to check your bracket is missing or not, or something like that. uh, but it is a combination of different algorithms, I guess, because let's say you forgot to write something like function and all, then different processing start. I guess it's there are like multiple processes going on your text id. to check if the typed content is valid or not. The algorithm is simple, that you will do the stack st, and for character c in your string as stack, right? Oh no, sorry, it meant a different thing. Target string to check if it is valid or not. Now this is my stack basically. If you are using Java, then it is different. If you are using C++, then it's this thing in, or char any data structure, or you can also use template, anything you can use. To check if a target is valid or not, we will create the stack. This is also mentioned in the PDF, by the way. So the moment you got if c equal to this, then we will just push it to stack dot push c. Else whatever, if it is not, if we got different characters, right? uh, 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 is this the right code? Wait, there are like multiple parentheses in the lead code task, right? Valid parenthesis. There are different parameters. Okay, so code I have provided in the PDF. I guess that's a different code I was talking about, like very simple task. Anyway, so all you need to do is if open bracket, like you can classify those brackets as like open bracket via e, and then if C is open, if it is categorized as open, then directly push it to stack. If it is closed, then it should have a matching pair. If it is not, then return false, that it is not valid. Let's write it differently. If C consists of open bracket class, open bracket class, then stack dot push C. Else, uh, now we know that if it is not open, it's a close bracket. Now we need to check whatever is at the stack end, like empty character or anything. You can always to not deal with the sizes, that if the stack is empty or not, always try to push something which I guess I have mentioned this in my previous videos. These are called sentinel values. So always try to push something to your stack so that your stack is never empty, right? So you don't need to deal that if the stack has size or not. You just need to do that this character will not be matched with any other character for implementation. So you don't need to check the size. So stack dot back should be matching with the current bracket, and obviously like this is the conversion of that open bracket basically. So if stack dot back is something like this, you will convert it to this. If it is this, you can convert it to this. If it is this, you can convert it to this. So you can store a map or something like this for implementation. I don't know why I am sharing implementation details with you. You are smart enough to do that, but yeah, something like that you can do. Then uh, if it is not the case, if it is not equal to C, then just return false. If none of the case is that, you can use a convert function, convert to opposite bracket, which will return the map from the here, and else return false. Else just pop it from the stack because it is matched. and in the end return true. This is very simple task, but I don't know why I'm wasting time in this. But anyway, let's start from simple. Uh, Everyone got this thing right. Like this is not very hard and very classic, I guess. Okay. By the way, this is the one thing. Another thing is you should also make sure not return true. This should be stack, should not be basically this is okay, but stack dot size should be always equal to 1. If you are using the Sentinel values, else you just need to make sure that your stack size is kind of dealing with that you don't have extra open brackets. So this string is valid, but the moment like if I just wrote return true, I will miss the edge case here, and I need to make sure that this pair here should be, if it is pushed to stack, I need to make sure that it is popped from the stack. So stack size should be either equal to 1 in the end, or if you are not dealing with Sentinel values, so stack should be empty. Anyway, let's jump to the second task, which is the, I guess this is asked to whom? Shreyansh, I guess. So if we have different open bracket, do we need to maintain different stacks for those? No, like if you maintain different stacks, uh, 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 could it be working? No, it will not work, because what will happen is because the definition of stack is this, right? Valid string is this. So if I did maintain different stacks, it will become something like this. You can add one here and then add close bracket here, and then this is not a valid string. But if you process this with different stacks, it will still give true, because this uh, we need to deal with the single data structure, because the definition is about that it should be valid, right? This is the valid parenthesis code. Uh, Now we will jump to minimum. Wait, we didn't. Okay. Anyway, let's skip the applications. Just focus on parenthesis sessions. Acha, there is another one. Maximum nesting depth. We will discuss 6 problems today. One is done, but few of them have very tough observations or multiple observations that might distract you and take you away from the actual logic. So you might be relying on luck or your pre solved task, like if you have already solved, then it's okay, but uh, we need to make sure that when you saw new task, you should be able to at least think in some direction, right? So I have written the thought notes are something like the bullet points that you should think upon whenever you see parenthesis task. First is the prefix sum, another is the left to right greedy. Most of the cases are I have seen are based on that. Anyway, so this is the second task, second lead course task. You can search it. uh, Maximum nesting depth. I have also added link in uh, lead this PDF, I guess. Okay. So depth is something that what's the this can be also called as what's the maximum space you would require to store characters in the stack, right? So let's say my now from like up after this question, like after first question, I will just use this open brackets, no other brackets. Like in the first task, I have used this curly braces or square brackets. We will not use that in our no task now, because let's say I started to use this, our dimensionality will get changed, and whatever greedy algorithms or whatever algorithms we will use will not be applicable in most of the tasks, right? So the task will get very, very complex. Like the moment you increase the dimensions, uh, in most of the cases, tasks become complex. So in task, they generally assume that this is the open and this is close. Okay. So maximum nesting depth can be thought as the maximum space you need to store in the stack, right? So let's say you are designing a software and you need to make sure that my space won't be needing more than that, like for the brackets and all. So you can use assume that whatever your maximum depth is, I will tell you what's the definition of depth here. So let's say if I had a stack, like usually I don't need a stack, I can just use plus one minus one and sum operation. But let's say I am using a stack, and the moment I got this string like this, four open brackets and four close bracket, to simulate my stack algorithm, I need to push it to stack four times, and then this bracket will remove this one, this will remove this. Again, like it's a mirror image, or this, this. By the way, don't get confused with palindromes and this brackets. Like this is not a palindrome. Like many people will get confused in this. Like this has been asked in many questions, that, and even like in code forces task, like if it is a palindrome string, remember that this is not a palindrome. If it was a palindrome, it would be looking like this. Sorry, this. This is a palindrome. So naturally, the first thought when you see strings like that, strings like this, you will get that this is a palindrome, but it is not. Okay. So the moment you reach toward the end, you will start popping. And by the way, like this is the depth that we went. Like this is the maximum space for vector. Usually vector have extra space here. Like there is a algorithm behind it to how vector increases its space, but it's something like this, that we push it and there is extra I don't know what we call it, but buffer space you can say, that we use to push or write to this memory, right? So there are like four open brackets and four close bracket, so the depth here is 4. Similarly, if you see like this, uh, my stack simulation will be 2 characters will be pushed, and then this will pop this one, this will pop this one. So here my depth will be at most 2, and here my depth will be at most 2 by processing. So total depth will be at most 2 overall. So this is the definition of nesting depth. It can be calculated very easily using a single variable, which is plus 1 minus 1. But using stack, you can also maintain other brackets if just needed to calculate. If we just need to calculate the maximum nested depth, then we can use stack. So we only need to use stack if there are like multiple brackets, else you can use some single variable to maintain the prefix sum basically. So in this case, it's plus 1 minus 1. So what we will try to do is, the moment we got open brackets, we will do plus 1 to our counter, and whatever highest value our counter reaches, that's our answer. Very simple, not very hard. That this counter equal to 1, counter equal to 2. The moment I got here, counter equal to 1, counter equal to 0. Then we again start from this, counter equal to 1, 2, 1, 0. So my counter has reached maximum to 2. So this is my nested depth. In this case, its counter has 4. So the maximum nesting depth in this case is 4. Okay, so this is the definition of maximum nesting depth and application. What else could I add to this? Depth, suffix depth, prefix depth. Let's ignore. Let's jump to the next task. These are easy tasks, by the way. We will jump to some medium tasks. This is the one. Minimum add to make valid parenthesis or like, let's say you are given a string or parenthesis or any kind of text and there are parentheses in it. So you need to make sure how many parentheses you need to add to make it a valid string. Now this is the dual task of dual, or you could say similar task, minimum remove to make valid. So basically the answer will be the same, right? Because what happens is whenever we do the addition, instead of addition, whatever open or close bracket was making us to add, we can just remove that and we will get our same answer, right? So let's say my s is something like this, right? And to make sure our string is balanced, let's say I added this extra, but instead of adding, what if I just removed this, right? So it will still be the same and my string will be still be balanced, right? So this minimum add to make valid is same as minimum remove to make valid. So if you are in the interview and you have been asked how would you convert your code to make sure that this is valid, so you can just use the same code for both of the tasks, whatever you have written. Okay, so this is the one thing I want to mention. Now let's jump to thought process. How, what could the thought process will look like for this? Mm, okay. So first thought process is, we need to make sure that whatever sequence I have got until now should be at least uh, don't have extra close bracket. That's our main goal. Like we are trying to solve this one, minimum add to make valid, because we can always convert it to minimum remove to make valid, but for now we are discussing this version. So minimum add to make valid, let's say I am here. Okay. Or I could use this kind of string. Okay, so let's say this is my target string and I need to first let's make a very easy case that I just need the count, how many brackets I need to add. Let's not convert it to how would the balanced version will look like, right? So what I will try to do here is just make sure that whichever close bracket is there, I will add open bracket somewhere in the prefix or at the start, you could say. That's the greedy goal. So either you can use DQ also, by the way, if you want to easily construct your sequence, but the algorithm or thought process will look something like this. Our target, our goal is to make sure that our prefix sum, which is also known as balance between open and close. So we will try to make sure that our balance is always greater than 0, that we have total higher number of open brackets than close brackets. Because the moment like if we maintain this thing, if we maintain that our balance is always greater than equal to 0, so in the end, let's say I have extra open brackets left, so what I could do is just add that many close bracket and I will be done with my answer, right? So our target or observation is this, that the balance between open and close should always be greater than equal to 0, or like the difference between like the count of open minus count of close should be greater than equal to 0. This is my target, right? So the moment I face open bracket, I will add +1 to my count. If I face close, I will do -1. Now it becomes 0. Now the I have reached here, so it is +1. Oh, sorry, -1. Now I know this -1 doesn't make any sense. So what I could do, either remove this, or I could just add it has different color, or I could just add here to balance it out with this. Like both I can do. Either I could remove this, or I could add another string here, right? So whatever version you prefer, like it doesn't matter. So +1 -1 is 0, and after that I will do -1, which becomes I know that like this is not valid. So either I could do +1 here, which is like adding open bracket to the start to maintain prefix sum greater than equal to 0. These are like multiple ways to say the same thing, but while implementation, you can use more mathematical stuff, right? So if the task is modified a little bit, you can just use the same prefix sum kind of stuff instead of just maintaining it, like the example in words, right? Like when you think in words, you are limited in your thought process, but when you think in maths, your thought process, you have more freedom towards that, right? Something like that. So what I could do, either add -1 +1, or just remove this -1, right? So either I could remove this, or either I could add open bracket to this. So that's the thing that we'll do. Whenever there is a prefix sum less than 0, we will add or remove that thing. So counter ++1, counter ++2, right here. And again, my counter got 1. No, sorry, counter, no, prefix sum got 1, prefix sum got 2, prefix sum got 3. Now counter that I removed or added open brackets plus prefix sum, that prefix sum is basically, now it means that I have extra 3 open brackets that I need to take care of. So my total count is 2 plus 3 equal to 5. Uh, Everyone understood this thing? What I have written here? Okay. I will write the pseudocode for count. Again, the same thing for char C belong to target. Let's call it prefix sum equal to 0. Let's call counter variable that whatever we remove, right? So if we got open bracket, we increase the prefix sum plus plus, else if C equal to uh, C equal to close bracket, then what we'll try to do, we will check if we have extra balance to make sure that if this prefix sum, because it's a balance, so if we'll check if prefix sum is greater than 0, it means that we can still remove this close bracket, right? So prefix sum minus minus, else we need to add extra bracket or remove that invalid bracket. So count plus plus, this is count, maintaining for that, right? And in the end, what we will return is this prefix sum plus count. That's it. This is the one thing. Now this is the easy part, because like this is just to, if we need to return the total count that need to be modified, or like because that's the minimum addition part, right? uh, Now what if what we could do to excuse me, Huh. Now let's say I asked you, uh, I don't need the count, I need the balanced string, right? Like let's say this is the one string. I will write it again here. Two close and three open. Like let's say this was the string. Now what my actual answer should look like, my return value should look like this. Orange part is the one that is added extra 3, no? This is for minimum addition. And if there is the minimum removal part, it should look something like this. Ah, we will remove the extra one. So instead of adding this 5 characters, I could just remove 5 characters from my string, and my string will look something like this. I have removed this. I have removed every 5 characters from here, right? So both of them are correct, right? Like this is the matching pair for this. But if you need to return this thing, we need to modify our code a little bit. So what I would suggest is, uh, mm, 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 huh. What I would suggest is, uh, because our, like, I don't know if this algorithm is well known or would it work, but I would suggest it to maintain a mirror here, right? To put a boundary here, like the moment you got open bracket, you can put the boundary here. So whatever, uh, because this is the balance boundary where the balance is 0, and the moment you got balance less than 0, uh, you could write extra character here, extra character here, like at -1 position, so which is the same distance from the balanced portion, right? So you can write it like this, and you face it again, you move here, you got extra, then like whatever the distance you moved from this boundary, you could add extra character here. By the way, this is not the space we have, this is virtual indexes or augmentation, you could say, that you are using this extra space or maintaining some map or some different thing that to maintain this kind of stuff, right? To write at -2 position or -1 position, right? So here we will start from 0 1 2 3, but my center of symmetry is this, where the balance is 0. Basically, you can always maintain that, or there might be some other algorithms too. Mm, 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 mm. Okay, let's try to think instead of addition. uh, for addition, I guess this should be the case now, like because we need to remove those extra characters, so we can append it at the start always, and for extra character we will append this at the, acha, then it's simple, like we don't need to do this symmetry stuff, forget this. Because all we need to do is add at the start, right? So just maintain the count, whatever the characters we need to add at the start. So what will happen is, here I have wrote prefix sum and count. So count is basically the open brackets I added at start, and prefix sum is just closed bracket added in the end. So all you need to do is modify your current string, target string, to something like this. That whatever the number of count is, you need to add that many open brackets count then target, and whatever the value of prefix sum is, you need to add that many prefix sum, that many close bracket. That's it. This is your return string. And similarly, now if it was not addition, if it was deletion, we could do the similar process. So what we could do is maintain some answer initially empty. So whenever we got open bracket, we will add it and maintain the same count. We will use it as a stack. If I got open bracket, I will add it. If I got closed bracket, after obviously this balance is not maintained, right? So the moment I got invalid, this string is invalid here. So I will just not add it to my answer. I got invalid. Sorry. Mm. Again I got invalid. So I will not add it to my answer, or add it and remove it, you could say. Any implementation you prefer. Not valid, remove it. Now I got valid, which is here. I got valid until 3 times, total 3 values. So 3 is added to end. In the end, my answer looks something like this. But it is still not valid because I haven't removed this extra brackets. So what you could do, that whatever prefix sum count you got, that many times you pop from back, while prefix sum minus minus, this I will pop. So in the end, my answer will look something like this. Minimum removal to make parenthesis valid. And if it was not removal, if it was addition, it would look something like this, that count open brackets and prefix sum close brackets in the end. And if it's just count, you need total count, then you can just return prefix sum plus count. Prefix sum, you can use balance word for that if you are more inclined towards using the word balance, but this is the way you can deal with it. You can also call it as 2 pass, because in the end what I did was like a pop from the end. You can also call it like this. Everyone with me for this? Uh, yes. Wait, sorry, I didn't. This approach is when balanced parenthesis. Shreyansh, you understood, right? Like, is Shreyansh here? This approach is when returning balanced parenthesis string is asked uh, instead of int value. Yeah. Is the algorithm computing the edit distance to the nearest balanced parenthesis? Algorithm computing the edit. You could say that like edit distance is same thing, that either add, remove. Add, remove to make it equal. Okay. I didn't got to complicate this task. Maybe I could have added more variations to this, but we could do this now also. That instead of mm, open close, what we could, how could we make new task with this? But anyway, like let's discuss first all the tasks that are mentioned in this doc, else we won't have enough time to discuss that. Where is the stack parenthesis? What was the fourth task? Fifth one. This is also a good one. Validity with star characters or mutable places, you could say. No, wildcard characters, you could say. This is the very good name for this, wildcard characters. So basically this thing. So usually this is the definition that you could use to definition or some placeholder, you could say, that you could insert any character in this mathematical word, that A, B, C, star, E. What are the total possible combinations for this? Total 26 combination, obviously, because if I consider lowercase characters, then what characters could replace star here? That's the wildcard character. So here the space is for only two, either this open bracket or close bracket. So the task is, what if I give you some binary string which is same size as my original string, right? Let me take the same example. That is uh, 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 uh. Okay. So this is the string example given in lead code task, first example, sorry. And my state looks something like this. So one means that I could replace basically swap those or change it to open brackets or close bracket, any character. Basically this means that I have freedom to change that character to some other character, but because here the other character is just a bracket, so it's just uh, x to y situation. Okay, so this is the task that we need to check not only if it is valid or not, but also if I can change the characters, then how to make the string towards valid if it is possible, right? So when I saw this task first time, like today, obviously, my first thought was to make sure to get a partition like stuff, right? Like something like this, that maybe I could insert a partition here, and what I could do, like whichever characters I need to change, I will add all those characters, uh, like inside the left portion of partition. I will convert all the characters that I have changed to characters that can be changed towards the open bracket. And in the right portion, I could whatever the target is to make sure the balance is maintained, right? So what I will try to do is in left portion, I will try to increase the balance, like by increase. I will write here. In left part, I was trying to maintain increasing the balance, and in right, decreasing the balance. So like I don't know why I thought like this, because it was like the let's say you have this, so it should be balanced on both side, left and right. Like if it is a base scale, so let's say I converted this greedily and this greedily, so there must be at least one partition that we have. uh, but then I thought, like, why am I doing like this? Because in the end I need to just balance the task, right? So if I need to balance, what I could do is make this left portion as heavy as possible, right? uh, so I could remove this one portion from here and insert on right side, right? So instead of making the partitions, I will just do this thing, that I will make the left portion of weighing scale as heavy as possible, something like this. So left, right, right. In the end, my balance should be 0, right? So my left portion should be as heavy as possible, and whatever the portion is here, size, weight right, weight left, First greedy target is to maximize the left portion, and obviously in the end result would be it will minimize the right portion, the balance, right? Balance is just whatever number of open brackets and close brackets are there, is basically something like that. So what does it mean exactly? What do I mean exactly uh, by putting as much as weight as possible on the left side instead of right side? It just means that I wanted to convert all the possible changing characters to open bracket, right? That was my first goal in the first class. That was a goal in the first class also, that whatever open brackets we are always satisfied, or like we are always good with open brackets, because the moment we got open brackets, those will be at the start, right? Something like this. So we don't care if those are extra, because the moment I got extra, I could just uh, change the one which is affecting the extra count, right? And we'll start from going towards right to left. Why is that? Because let's say this was the string which was mentioning that if I could change the character or not. So what I will try to do is to, as greedily possible, like as much as possible, I will change all the characters to open bracket. So in the end process, uh, my balance will be greater than equal to 0. This is the best possible scenario, right? But let's say my balance is still less than 0, then obviously string can be balanced. Similarly, if uh, if my balance is odd, basically, I guess in that case also you can't, I guess, right? uh, in odd case also, but anyway. So this is the thing, that what I will try to do is convert all the changeable characters, star characters, to open bracket, right? So in this case, what will happen? This was the target string initially, and 010100. So second and third port, this one. So what I will try to do is change this to open bracket. So in the end, what will happen is, wait, 0 is locked. Yeah? One sec. How is this working? Acha, okay. So if locked is 1, you can't change. Sorry, my bad. I forgot the definition. So basically 0 is the one that I could change. This. So this character, this character, this character. So I will convert them to open brackets. Mhm. This is already open, but I will still write it as open, closed, open, open. So the orange portion are the change string. Now you can see that my balance is something that is greater than equal to 0 in the end after this conversion. So whenever there is 0, what I will try to do is convert that to open bracket. So my left portion is as heavy as possible, because obviously I could distribute the weight later, but the first target is to distribute the weight as much as to the left part. So here I did the same thing. I converted as much as open brackets I can to make sure that my balance is greater than equal to 0. Because in the end, I know if I have extra open bracket, I will convert the rightmost open bracket to close bracket, like whichever I could change. And in the end, it will become balanced. So That's the greedy procedure instead of partition one. Partition complexity was n square because I need to figure out like what was the what's the weight on left side, what's the weight on right side, something like that. I guess you could use different analogy for this, not just this weighing scale analogy. You can just think it as like a greedy approach. Greedy approach. If you don't wanna, because this is my own thought process, you could think in terms of greedily that I will try to add as many as open bracket as possible. Obviously that's for my own benefit. Then I could now once that I did that, I will just try to convert all the close bracket. But here the balance is zero basically, so we don't need to convert any open bracket to close brackets, right? So if that wasn't the case, I just need to convert this balance to, if let's say balance was 1, I could convert. And what does balance 1 means? It means in the end I have extra open brackets, so I need to convert those to close brackets, right? And what will happen in due to that, my balance will become minus equal to 2. So it means if I need my final balance to be 0, this is because my final state. So if my balance after making this changes is odd, then answer is not possible. Because the moment I change that open bracket to close bracket, uh, I will remove the one contribution from the portion that was added, and one contribution from changing that to -1, right? So because 1 to -1 is 2 ka difference, so I need to remove this from my balance, right? So in the end, my balance can't, after this procedure, my balance can't be odd, because obviously odd minus 2 is odd. So it will never reach 0 basically. So that's also the case. Example 2 in lead code task is already balanced. Let's take example 4. Oh man. Three open. One this. Again, 4 open. 2 close. 4 open, 2 close. 4 open, 2 close. Okay. And the binary string is 6 times 1, 0, 1, 0, 1, 1, 1. 6 times 1. Then 0, 1, 0, 1, 1, 1. So basically all I could change is these two characters, right? And those are already open brackets, so I don't need to change them. So I could skip the step 1, that is convert all changeable characters to open. We could skip this step. I'm not wrong. Skip. We can directly jump to step 2, which is whichever open brackets I have, in the end I will just mark them as a closed one, right? So in the end, let's check the balance here, which is 1 2 3 4 3 2 5 6 7 8. Wait, sorry, 4 2, then 3 4 5 6, then again 5 and 4. So here my balance would look something like this: 1 2 3 4, then -1, which is 3 2, then again 3 4 5 6, then 5 4. So in the end, I need to convert all the open brackets uh, like this. Because I have extra 4 here, because I need minus 1 here, right? Like I need the balance to be 0. So I need to convert 2 extra brackets to the balance here is 4, right? So it means I need to convert this many open brackets divided by 2 basically, because the moment I convert this bracket to this, this plus 1 becomes minus 1. So my balance becomes balance equal to 2, right? So let's say get the first open bracket, uh, 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 this one. This is my first open bracket from the right. Why from the right? Because I am trying to greedily match it as possible. Because let's say I started matching converting from left side. So what will happen is we will get here extra. The balance should be as, to maintain the balance greater than equal to 0, it is beneficial to make sure to convert the characters at as end as possible, right? Because uh, as many balance as many plus characters we have at the start, it is beneficial for us to make sure that prefix sum is always greater than equal to 0. So it's always beneficial for us to convert this characters, right? So I will convert this character, one character, to this, and after this conversion my balance will become 2. It is still greater than 0, right? So I will convert this character to, and my balance will become 0. That's it. So in the end, my string would look something like this after step 2. Oh, sorry. This. And you can see it is balanced now. This is matching with this, and this is matching with this. This is matching with this. This pair, this pair, this pair, this pair. Everything is matched. You can see. Obviously, you don't need to check this one. You can just remove it. This is matched with this. This is matched with this. This is the algorithm for this. We are just greedily matching the prefix basically. And our target goal is to maintain as much as possible balance towards the left side, right? But the moment I started uh, converting from the start, that is not beneficial for us. Our benefit is to go from right to left, and that's what we do. uh, Whoever are online are listening to this, right? Wait. Sorry, I didn't read the comments. Before decrementing, is this enforcing a non-negativity constraint and prefix become invalid? Which portion are you asking about? If star is a random choice, what is the probability the whole string is valid? Uh, Probability. Okay. The whole string is valid, and if high greater than 0, does this mean even the based optimistic interpretation fail? I didn't understand your question. Could you like ex ask ask using voice? Like I didn't understood that part. Like even the based optimistic interpretation fails. Like our target is to make sure that we have.
Like if high is greater than 0, invalidity for checking invalidity. If high is greater than sorry less than 0, that does this mean amplify the best optimist?
Acha, okay. So you are getting the height interpretation. I was
Yeah.
not getting into that height interpretation. So height interpretation is something like that. We are kind of converting. We are not making the height to be less than 0. The moment I got height less than 0, I will convert it to +1, basically something like that.
But if low is equal to 0, does that means the left over open brackets will violate the validity? Na? Like if is there is any possibility for that? Like intuitively, if you check the sequence from the leftover opens,
You are talking about the code, right? Like in the one second.
yeah, like if low equal to 0 or balance.
Wait, let me check that one. Acha, ha, ha, ha. So you are talking about that low is basically as much as low I can go, and low can't be greater less than zero. Basically, that's the case. And high is as much balance as I'm maintaining as that.
Okay.
Because I could convert wait a second, like star counts as +1 for high, and if it is not, basically the same thing, that if it's open bracket, it's a -1. Mhm. If high is less than 0, uh obviously, like if the balance is anywhere less than 0, you're using the optimal conversion, like as greedy as possible. Like, see, if you convert, if you check the variables low and high, the high part is maintaining that my balance is always greater than 0, right? So if greater than equal to 0, basically high is just the prefix sum. So the moment I got that, I could say my I could say my prefix sum, or like my balance is greater than equal to 0, basically. But if my balance got less than 0 even after like converting all the changeable characters to plus, then obviously that's the red flag, that I can't do that, because there must be some case that I can't convert those I can't match those close bracket with open brackets even after changing. That is the high part. And low part is basically low is equal to max of 0 comma low. It just means that I am converting those characters. uh, I don't know if it is valid or not. Like, this is GPT generated, little the code is, I didn't write this code, but I think low is equal to max 0 comma low. Mm, it's just maintaining the wait, right here. So the code is something like this, that low is equal to 0, high is equal to 0, C in S, low plus equal to the same thing balance, high plus equal to, so high is just prefix sum, and low plus equal to whatever the bracket value is, like +1 -1. But the only change we are doing in the low is that low must be clamped. Acha, clamped is the word. Treat wildcards as this thing, but this is only when it's a wild card, right? And because it's a wild card. Acha, ha, I noticed that we have changed this code after optimal conversion, I guess. This is the thing. This I, because there is no locked string in this, right? Like this in the PDF in check valid string, there is no locked string. Uh, the only portion, this is after conversion, all the close bracket to open brackets, basically. So it's the same thing. Whatever we did here, na, like whatever we maintain the balance.
So there are no leftovers of opening in the both sides.
Wait. Could you repeat your question? What was your query again?
Like, so there will be no leftovers, right? At the last
Leftovers of what? Like open, close,
opens.
opens. No, there will be no leftovers, because that's just to maintain we have extra balance available.
Okay.
High portion is maintaining that, low portion is maintaining that our but I'm still not sure if it is valid or not, because let's say Acha, because high is maintaining one thing, that our balance is always greater than equal to 0, right? So low is equal to okay, I got it now. So low equal to max 0 comma low is working because of high, because high is responsible to make sure our balance is always greater than equal to 0. if I'm converting that to open characters, right? And low is basically converting all the characters to always make sure that our balance is never greater than 0. It's always greater than 0 basically. That's the thing. You can use both the algorithms, doesn't matter. It's the same thing. What I tried to do here was to maintain the balance to be always greater than 0, right? By converting all the string. Here we did the same thing, that first convert all the brackets, changeable brackets, to open brackets, so that I could maintain this high in prefix as much large as possible, right? So it will never get less than 0. That's the greedy approach basically, to keep the high variable as large as possible. So my low variable is just maintaining the open bracket count. Now because my high has already maintained the balanced portion, that after changing the changeable bracket to close, it will still be balanced. So I don't need to worry about that if this will work correctly or not. I just need to convert this. If there is extra open close brackets, I will just convert them to the balance to be 0 basically. So if my balance goes to negative, I will just convert that to 0 instead. For example, I will show you like this. This is the star character, right? Whatever. Just huh. So how this algorithm works is something like this: that this star is converted to open one. First, I have converted all these to open ones, right? Now, what I will try to do is something like this, because these are the changeable ones. I already changed them to open one. Now I will process this string. So high will look something like this: 1, 2, 3, 4, 5. Now my low should be always equal to 0, but in this case it is, I haven't added some extra variables, but I will add it here. Oh, अरे यार, I took some wrong example. Okay, 1 second. So low is basically, it should be always pointing towards 0 in the end. That's our target. uh, it just means that the number of close brackets should not be greater than 0. It should be always.
So that it means that prefix condition never goes negative, right? Like,
That's it. Like, high is to maintain the prefix sum is greater than equal to 0, and low is to maintain the prefix sum is not less than 0.
yeah.
That's it.
If it becomes less than 0, it becomes invalidity. The string can't be valid. Like if
But like
if,
we don't care about that. Now, like high is already maintaining that part.
okay. Got it.
So they are maintaining the range basically.
Yeah,
Whatever
low
the,
comma high. Right?
right. So this portion I'm clamping to 0, and high is basically as much as possible, because I know I can convert this high to low, but I just need to maintain this range.
That range will capture all it captures all the brackets, right? Open
So
brackets. Yeah.
it basically maintains the balance basically from the
Yeah.
prefix until that.
Got it.
Now because my low was always clamped to 0, right? Because my low was always clamped to 0, and I'm always trying to decrement it, not increment it, right? So if in the end my portion was 0, because I'm greedily trying to decrement it, like whenever there is changeable characters or open brackets, sorry, close bracket, I'm trying to decrement the low. So in the end my low should be equal to 0, because I have maintained the clamped range of low, right? Like I don't know, like many people who will watch the video will get confused about this code. But if you guys get confused about this, because I know how this works, but like to explain it, it's a little bit weird. But you can easily understand this balance approach. Like this is the same thing, that high is maintaining the positive balance, right? And low is maintaining the balance to be as low as possible, but not less than 0, obviously, because high has taken care. And if we can convert that to, but one thing I'm still curious, if my balance is odd, is it possible if my balance is odd? what happens in that case? Because it will work, but because acha ha.
Can
I
balance
thought
only odd numbers, right? If
ha.
balance is odd.
Then in that case low will be equal to 1, or like odd number, any odd number, because low can be greater than equal to 0, right?
Yeah, there is no way of 0.
There is no way it can go to negative, but like let's say my string is something like this, then in this case low equal to 1.
It can be all odd numbers, right? Like any odd, all odd.
Sorry, what? All or?
Like if low equal to 1, high can be all odd, like 3 or 5,
No,
like that.
high will be here 1, na? High is equal to 1. But I was curious, how does this algorithm check if there is a extra open bracket, one extra open bracket? Because my algorithm was something like this, that in the end, if my balance is odd, then obviously answer is not possible. Because in the end, my balance should be equal to 0. But whatever conversion or subtraction I'm doing, that changes it by -2. So it always converts to even number to even number. But if the balance was odd, so if it was 3, let's say, so in the end it will go to 1, and it can't be converted to 0 then, because it will always convert it to -2, right?
Yeah, it becomes invalid.
So that's what I was checking. So in this case, that balance is checked by the low variable. Okay, I guess this is too much discussion for 1.5 hours. Man, I wanted to also discuss the sixth task. Uh, there is also height approach I wanted to discuss, but I guess we could do separate session and add more tasks on this, because there were so many tasks on parenthesis. Rest of the people have any queries? Wait, sorry. Whenever over count goes below 0, we will convert into open bracket. What's over count? Acha, ha, over count below 0. Yes, exactly. That we will convert that. That interpretation does mean exactly that. Like whenever we are doing low equal to 0 max of low, and if the low got less than 0, we are converting that close bracket to open bracket. Yes. So it's the same process that we were doing, but instead of -1, we are doing like instead of -1, we are adding +2 to that, and it will become +1 basically. So balance will be, we are trying to get the balance to be low boundary is pushed to 0, and high boundary is just maintain the total balance basically. Different interpretation of the same task.
Yeah, so
Any?
yes, I have one question. So basically, what we are doing here is, so first whatever star mark, whatever character we are getting, right, we are converting them into open brackets,
Ha.
and putting them in stacks and removing them as most as possible. And at the last, if the stack is not empty and it is not an odd number, if it is odd, it is not
Acha.
valid.
You are trying to get the interpretation via stack. Okay, let's repeat your question again then.
Yes. So for this approach, right, as you explained this one. So if we have these wildcard characters, right? So we are
Mm-hmm.
putting all of them first in the stack as open brackets.
Open bracket, yes, exactly.
Yes. And then popping them out when we are finding any close bracket, right?
Correct.
So after the first iteration, if we get any like if the stack size, because stack contain all the open brackets only currently, if it is not empty and if it is odd, then we are getting it is invalid. But the size is not odd, then we can pop out the half elements from the stack and convert them to open brackets, right?
Exactly, correct. The whichever stack remaining characters are there in the stack, we can convert half of the characters to close bracket and convert that balance to 0.
Okay, okay. Then it will work, right? Okay, thank you.
Any other query? Okay, then we will do some other session and we will also discuss. I also wanted to discuss the monotonic stack thing, like one to many approach. But I will add that to separate session or prequel to this session, I guess. So let's summarize this. Like today we discussed this prefix sum and greedy approaches, but I also wanted to discuss the height approaches, which was in the sixth class, but I guess we didn't have enough time. Mm, Still, I tried to cover many things. But anyway, like we discussed definition of stack, we discussed the flexibility of things, not important by the way, applications of stack, parenthesis definition, common thought nodes that we discussed. This will discuss in separate session. Valid parenthesis, how to check the validity for, like, obviously this is if we are using a stack, you can check the validity. In that case, dimensionality doesn't affect much, but if you are using a single variable, so in that case you need to use different variable. Basically, why you can't use single variable? Because you are using only on x-axis, but the moment you deal with multiple variables, you need to add this to here. So in the end, you should land on origin basically if you are using a single variable. So it won't be called as a single variable, it would be called as, but I guess would it work? No, it will not work the same way I discussed. I guess that it will not work because for strings like this, it will not work. But we can modify the definition itself. We can modify the definition that I cap, j cap, and k cap, let's say, is the direction, right? And whatever the value is, it's this value should always be greater than 0. No, it will not work, I guess, because for this I will do plus. Basically, it's just maintaining 3 stacks, na? So it is not valid. Anyway, forget about it. Not valid. This is the stack variation that if it is valid or not for every type of bracket. If it is open bracket, then just push it. If it is a closed bracket, then try to match the character and with the back character stack. Else, pop from the stack, though whatever the open bracket you have pushed, because that's the matched one. And in the end, if your stack size is not equal to 1, because I have Sentinel values, then false. Depth minimum add to make valid, dual of minimum removal to make valid. Any queries in this, like how it is dual or not of each other, how we were dealing with prefix sum and count to make the answer a target string. And wild characters. Guess this is discussed in detail. So, okay, I will stop the recording if you want to ask something off recording. Stop.